Imagine standing in front of like a curved video wall the size of an office building. The image is flawless and seamless.
Right. It looks completely perfect.
Exactly. But what you are actually looking at is an incredibly complex optical illusion. Okay, so let's unpack this. Welcome to our deep dive.
Yeah, we have a really fascinating technical spec sheet to tear into today.
We do. It is from HDTV Supply, covering this heavy-duty piece of AV gear called the Avenview MLT-EdgePro-2X2E 4K30 blending video wall processor.
Quite the mouthful.
Oh, absolutely. But our mission today is to decode what this $5,198.67 machine actually does.
Because it is basically the invisible magician making all those physical seams completely disappear.
Right, because the magic isn't really in the projectors themselves, is it?
No, not at all. It is entirely in how this device manipulates the video signal to, fool your eyes before the light ever even leaves the lens.
Okay, wow.
Yeah, it takes up to 5 inputs and outputs to 2 HDMIs at 4K resolution at 30 Hz. And its whole existence really revolves around 2 things: edge blending and image warping.
Okay, wait. Here is where I have to push back a little bit, because I get that software-based edge blending exists.
Sure, absolutely it does.
Like you can do this in media servers, things like Resolume or Dataton Watchout. So why drop over $5,000 on a standalone hardware box just to bend an image?
Well, what's fascinating here is that doing this purely in software requires just immense computing overhead.
Right.
And even then, it often struggles with the actual physical reality of the projection surface.
What do you mean by the physical reality?
Well, think about when you overlap 2 projectors. Even if you line them up perfectly, you double the brightness in that overlapped seam.
Oh, right. Because you literally have twice the light hitting that one spot.
Exactly. It creates this ugly bright band. So this Avenview unit processes everything at 10-bit color depth, and it uses a feature called non-overlapped area black level uplift.
Wait, so it artificially brightens the darker, non-overlapping parts of the projection just so they perfectly match the doubled brightness of those seams?
Yeah, it balances the entire canvas so the illusion holds up.
That is wild.
It really is. And for the warping itself, it doesn't just stretch the 4 corners. It places this complex 17 by 17 grid over the image.
A 17 by 17 grid.
Yeah, which gives you 289 independent anchor points. You can grab any single point and digitally push or pull those pixels so they wrap perfectly around, say, an irregular physical pillar.
Or like a huge curved stadium wall.
Exactly.
Okay, so it perfectly blends 2 projectors, but a massive 360-degree setup out in the real world uses like dozens of them.
Oh, absolutely. Sometimes hundreds.
Right. So if all this 289-point warping and pixel-level color correcting is happening in real time, how does the system not just buckle under all that math?
Well, that is where the HDMI loop-out feature comes in.
Yeah, I saw that on the spec sheet. It's less like a single computer trying to force outputs to 50 monitors and more like snapping Lego bricks together, right? Like a bucket brigade.
That is a really great way to picture it. One processor grabs the specific piece of the 4K image it needs for its assigned projectors.
Okay.
And then it just passes the exact same uncompressed signal right down the line to the next unit. So you just endlessly chain them together without ever degrading the original source video.
Which actually brings us to the craziest spec on this whole sheet.
Yeah.
This is all achieved entirely without a PC.
And if we connect this to the bigger picture, that is the exact reason commercial integrators gladly pay $5,000 for it.
Really? Just to avoid using Windows?
Kinda, yeah. When a standard PC tries to process fast-moving video across multiple 4K outputs, it drops frames. It causes the video wall to tear or stutter.
Oh, like when a video game lags.
Exactly. But this Avenview box uses dedicated silicon to handle the math natively. It performs features like motion-adaptive deinterlacing.
Which basically just keeps fast-moving video buttery smooth, right?
Yeah, because it isn't fighting a bloated operating system for resources.
Right. The video stays fluid. And more importantly, you don't have to worry about your building-sized immersive display suddenly minimizing because a computer decided it's time for a mandatory background update.
Precisely. You remove the PC, you remove the biggest point of failure. It is purpose-built to do exactly one thing in real time with absolute stability.
So what does this actually mean for you listening at home? Well, the next time you walk past a massive curved video wall or see 3D projection mapping wrapping around a building, you will know it is not just a big screen.
Right. It's a massive optical puzzle.
Exactly. It is being stitched together, pixel pushed, and color matched in real time by dedicated hardware just like this Avenview processor.
It really does completely change how you experience digital displays out in the wild. You start looking for the seams.
It totally does. And it leaves me with this thought for you to chew on today. If dedicated hardware can flawlessly warp, blend, and map digital reality onto irregular physical spaces entirely without a computer, what happens to our physical environment when this level of real-time geometry mapping is miniaturized?
Oh, wow, yeah. Like into the everyday smart glasses or devices you carry with you.
Exactly. Because suddenly, the magician isn't just hiding the seams on a video wall. They might be redrawing your entire world.